Our final examples will all revolve around the sum of a series, geometric series, and pretty much all of these revolve around the sum to n terms of a series formula, which looks like this, that Sn is equal to a outside of r to the n minus 1 divided by r minus 1. Now this is one form. You will also see it in this form, okay, where the 1 and the r are swapped around. These are equivalent, and you can show relatively easily that these two statements are equivalent. It's a relatively straightforward process in algebra. I tend to prefer the first one. Some textbooks will ask you to learn both of them and then expect you to use one in some cases and the other in other cases. Really, you only need this one. The only advantage to learning both of them is sometimes it'll save you from having to deal with a negative, but I think you can handle that. They're not too bad to deal with. So this is our sum to n terms formula. For this very simple first example, we're asked to find the sum of the first 6 terms in this series, 1 plus 3 plus 9 plus so on. So first thing we should do, as always, is determine what our first term and what our common ratio are if possible. Our first term is 1. Our common ratio is found by dividing subsequent terms. 3 divided by 1 or 9 divided by 3. I'll go the more complicated one, who cares, it's 3. Okay, ratio is 3. Now we need to work out the sum to the given number of terms, which is 6. So the sum to 6 terms is going to be the first term, 1, times r, which is 3 to the power of 6. Take away 1, divided by the ratio, which was 3. Take away 1. We can pull a calculator out here. I personally do not know what 3 to the power of 6 is. Oh, and my calculator on the side is being a bit strange. 3 to the power of 6. Okay, it tells me that that is 729 minus 1. I've kind of gotten rid of the brackets and the 1 because 1 times this thing is just this thing, so I've left it there. 3 minus 1 is 2. So let's do this top here. 729 minus 1 is going to be obviously 728, and then I want to divide that by 2. Will give me 364 as the sum of the first 6 terms in this series. So the advantage of having this formula and being able to use it like this is I got this total. Oh, that is the worst box I've ever drawn. I got this total marginally better without having to determine what those 6 terms were and then add them all up. I can just plug the numbers into the formula and it'll get me an answer. You won't see too many really large numbers in here because obviously these numbers get huge as you go along the series, but this simple example does illustrate the power of a formula like this one.